Find the equation for parabola in standard orientation with focus at -2, 3 and the directrix line y is equal to 1. So let's plot the focus and the directrix line and let's see what's what after that. So the focus is at -2, 3. So 2 to the left from the origin and 3 up. So the focus is going to be right here. And the directrix is the line y is equal to 1. Y is equal to 1 is 1 above the x-axis, right? And it's going to be a horizontal line parallel to the x-axis, right? So we know this is going to be the directrix line. Okay? So that's going to be y is equal to 1. So we know that the vertex has to be right in the middle between the between the directrix and the focus, right? So we know the parabola, and the parabola should open away from the directrix line, right? So we know it should look something like this. Okay? So we need to find the equation of this parabola in standard orientation. So we know that it's opening up based on the observations made in the graph. So if it's opening up, we know that the equation that we're looking for should be of the form x minus h squared is equal to 4p times y minus k. Okay? Now hk represent the vertex coordinates, right? Vertex coordinates. Okay, so the vertex coordinates. Now the vertex coordinates are what? It's going to be, as we know, the vertex is right here, right in the middle between the directrix line and the focus point, right? So we know that's a point, and that's -2, 1. Okay, so h is -2, k is equal to 1. So -2 is pretty easy to see, but the k, if you want to know algebraically how to get k, just simply get k from finding the average of the focus and the directrix, right? So it's going to be 1, the y value 1, plus 3, the y value of the focus, divided by 2, right? Because that's what you want, and that's going to be 4/2, which is 2. Okay, so k, yeah, I'm sorry, I don't know why I put 1 there. It's the distance from the x-axis, so it has to be 2. You see, that's a powerful way to check yourself in case if you're wrong. Always use this formula, just in case. Depending on the orientation, in this case it's opening up, so we know that the k is going to be the variable here. And the x value is going to be the same, right? H is the x value, which is the same for the vertex and the focus and the directrix there, right? It's on the same vertical line, so to speak, the axis of symmetry line, okay? So just note that this is the axis of symmetry line. It goes through the vertex, right? So we know the axis of symmetry line contains the vertex and the focus. Okay, so we know that the h must be also the same as the focus x coordinate, which is -2. But the k in this case is going to be found by using this formula. So in case if you're wrong with your k, like I was, you check yourself to be sure that it's the correct coordinate, right? In this case, it's 2 above the x-axis. My mistake was I was counting from the directrix line and I thought it was 1. But you see, you always have to check yourself, because mistakes do happen. Directrices sometimes look like major axes in the xy plane, so you have to be careful. So I got that correct. So h is -2, k is equal to 2. Now what is the p-value? The p-value is going to be the distance from the vertex to the focus, and we know it has to be a positive value. And in this case it's simple, right? Because we go up anyway from the vertex to get to the focus, right? So p is equal to 1. So the equation that we want is x minus h value is -2. So -2 squared is equal to 4 times 1, the p value that we found, y minus, and the k value is 2, so it's that. Right, so as a result, we get x plus 2 squared is equal to 4 times y minus 2. So what this gets us to is x squared plus 4x plus 4, I'm just expanding the left side, is equal to 4y minus 8. What this gives us is x squared. Now we're going to subtract basically 4y, and we're going to add 8 on both sides. So as a result, what we should get is x squared plus 4x minus 4y plus 12 is equal to 0, right? So this is going to be your equation of the parabola in standard orientation. Thank you so much for watching, and I'll see you in the next video.